So our lesson, areas and volumes of similar solids. This is the last lesson of this chapter here. In this chapter, we will learn how can we compare and find the areas and the volumes of similar solids. We say that to compare between them, we need to use the ratios. And we said here that if you want to write the ratio for two solid figures, you have to write or to list all the length or the dimensions of each corresponding sides. As an example, the first one here, we have 3. We compare like this length, this length with this length, and I can write it as 3/6. And also, we can compare this one, the height with this height, and we can write it also as 3/6. And the last one, which is the width times the width, which we can be written as 2/4. Now we have to compare if these three ratios are equal or no. Is 2/4 equal 3/6, which is equal also to 3/6? All of us know if you want to compare between any fractions, we must simplify them or write them with a common denominator. We can simplify them now as 1/2, 1/2, and 1/2. And as you see, for the three scale factors which are equal, we can say now that the two prisms are similar because the corresponding dimensions are proportional. So because of that, we say that the scale factor will be 1/2. But for the second one, as I told you, to say that if these two prisms are similar, we have to compare each length or each dimension or each corresponding dimension, this 3 with this one. We write it as 3/6. Is it equal to 2/3? Is it equal to 2/3? As I told you, to compare between them, we have to simplify. The first one, it can be written as 1/2. Does it equal to 2/3? And does it equal to 2/3? As you see, they are not equal. The three ratios must be equal. Since one of them is not the same as the other two, so we say that these prisms are not similar because we compare the corresponding dimension. They are not equal, so they are not with the two shapes are not similar, so there's no scale factor for these two shapes here. This is for these first, this is the first ideas. Now, we say then, like how we did in the lesson in chapter 10, we will make here in chapter 11. Like in the previous lesson, we have a scale factor. We can write the ratios of parameter and the ratios of area. Here, the same. We have the scale factor, but we can write now the ratios of a surface area and the ratio of the volumes. Now look at these two similar prisms here. These two prisms now, let's start with the dimension. Let's write the scale factor now. So to write the scale factor here, let's write it here. The scale factor here, since they are similar, so if I compare or if I write any corresponding limit, they are and they are proportional, I can write the scale factor. So let's choose this one, 2/4, you can say, or 1/2, or 3/6. Choose any one from them. If you try them, you will write now the scale factor. 1 over 2. This is our scale factor. Now, let's compare now between the surface area of both of them. You will see it's 22 over 88. If you simplify them, you will say that they are 1 over 4. And the 1 over 4 is the scale factor squared. So the ratio of the surface area is the square of the scale. As you see, 1 is a square of 1 and 4 is a square of 2. So the ratio of the surface area is the square of the scale factor. Now let's compare the volumes now. They are 6 over 48 over 1 over 8. So it is 1 over 8. This 1 over 8 is the ratio of the volumes is the cube of the scale factor. So here, and these are the two facts that can be applied to all similar solids. If they are, so in the previous problem here, we have to check if they are similar or no. To check if they are similar or no, we have to write all the dimensions. If all the dimensions are proportional, I can write the scale factor. Here, I told you that they are similar. I told you that each dimension are proportional. So you can write the scale factor. Since you can write the scale factor, as we said, like 1 over 2 or 2 over 4 or 3 over 6, all of them are correct. If you choose 1 over 2, which is the scale factor, you can write the ratios of the surface area, which is the square of the scale factor, and we can write also the cube of the scale factor, which is the ratios of volume. So look at now the theorem here. If the scale factor of two similar solids is A to B, then the ratio of their corresponding areas will be A squared to B squared, and the ratio of their volumes will be A cubic to B cubic. This is how can we write the ratios. Let's now find here the scale factor. Now, the square prism at the right are similar. What is the scale factor of the smaller prism to the larger one? I want
first take the cubic root of the volumes.
Yeah, here now we have to write the scale factor. The scale factor, which is A over B. But here I have now the volume of the first shape and the first figure, sorry, and the volume of the second figure. So if you compare now the volume of the first one with the volume of the second one, we will write A cubic over B cubic. That means if I compare between these two volumes, I will write the cube of the scale ratios. This is the cube of the scale ratios. So it's like 729 over 1301. Let's now simplify them, and easier for me by calculator here. So if you divide now,
it's 9 over 11.
729 over 1331, it will be 9 over 11.
I got it as that.
Wait, let's divide it like.
It can't be divided. Like it's the simplest one.
Let's do something first here. Yeah, here now, yes, this is 729. This and 1 over 3,301. Let's take now the cubic root of it. Before this step here, we said that this is A cubic, or cube A over b cubic. But this is now the cube of the cubic, sorry, of the scale factor. But I need the scale factor. So what I have to do, let's take the cubic root here and the cubic root here. If you take now the cubic root of 729 over 1301, you will find that it is 9 over 11, which is a over b. And this will be now my scale factor. Is it clear?
Yes.
Yes. Teacher.
Yeah.
Okay, let's have now another example here.
Teacher.
Yes, Lama?
Can you repeat the last part?
Okay. Here now, in this part, Lama صح? But your name is Muhammad here.
Yes. We'll change it.
Okay, no problem. But you are Lama. Here now, you wrote, oh, I have the two volumes for the smaller prism and for the larger prism. If you compare between these two volumes, you will write the cubic of the scale factor. As you see, it's a cubic over b cubic. So this is the cubic of the scale factor. How can, but I need a over b. I don't need a cubic over b cubic. The scale factor I want to find it is a over b. But here I have a cubic over b cubic. Or it can be written as a over b cubic. So I need a over b. What I have to do, I have to put the first term here under cubic root and the second term here under the cubic root. Is it right? If you want to write to cancel the cubic, you will put it under the cubic root. Then it cancel each other. So a over b, it will be, let's write it, do it in your calculator, write a cubic root of 729 over 1331. You will find that it is 9 over 11. Let's have another example here. You will understand more. In this one here, they didn't give me now the volumes. They give me the surface areas of the first figure and the second figure. They give me the surface areas. So the data here is or are the surface area of the smaller one and the surface area of the larger one. And they ask me to write the scale factor, which is a over b. Now, we said that if we have the scale factor as a over b, we can write the ratio of the surface areas, which is a over b squared. And also we can write the ratios of the volume, which is a over b cubic. So here now we have to go in the reverse way. What does it mean? That means I have the ratios of the surface area and I need to find the scale ratio. Sometimes I give you the scale ratio like 2 over 3 and I told you write the ratios of the area. You will tell me that it is 2 over 3 squared, which is 4 over 9. So I give you here the scale factor, you square it, so you will write now the ratios of the area. And if you cubic it, you will write the ratios of volume. But here now, no, here I will give you the ratio of the scale factor of the areas of the surface area, and I ask you to find the scale factor. How I solve this one here? Here now, to find the scale factor, which is A over B, this is I want to find. I have only the surface area for the two solids, which can be written as the surface area of the first prism over the surface area of the second prism. If you write the ratios of them, which is 144 over 324, these two numbers now are equal. Since I'm talking about surface areas, so it's equal to A over B squared. So the ratios of the surface area is rewritten as A over B squared. This one is the ratios of the surface area, but I didn't need it. I need A over B only. So what I have to do, just put each of the two terms here under the square root, yes, which is 12 over the square root of 324. Is it, I think, 17 times, no.
18.
Oh, it's 18.
18.
So scale factor will be 2 over 3.
So here, it is 12 over 18. This is now the scale factor. This is what I want to find. And you can also simplify it here as divide by 3 is 4, divide by 3 is 6, by 2 is 2, by 2 is 3. So it can be written as 2 over 3. Is it clear now, Lama?
Yes, thank you.
You are welcome. So here I will repeat. If I give you the scale factor here, so by now we have two ideas. I give you the scale factor and I ask you to write the ratios, or the ratio, sorry, of the surface area, and also I can ask you to write the ratio of the volumes. Now, the scale factor, it can be written as A over B. The ratios of surface area, it is A squared over B squared, or A over B squared. The ratios of volume, it can be written as A cubic over B cubic, or A over B cubic. Now, I can give you the scale ratio, A over B. You can write the ratio of the surface areas or the ratio of the volumes, like 1 over 4 is the scale ratio. If I ask you to write the ratio of the surface area, what you have to do, just to bring this number
It will be squared.
squared, which is 1 over 16. And for the ratios of volume, it will be 1 over 4 cubic. Yes, this is the first idea. The second idea here, that sometimes I give you now the ratios of volume or the ratios of the surface area, and I ask you to write the scale factor. So you have to go back. Like, if I told you, like, this is 8 over 27, this is the ratios of volume, which is A over B cubic, and I asked you now to write A over B. What A over B cubic? All of us know that if you want to cancel the cubic, put them under the cubic root to find A over B. The cubic root of 8 is 2, of 27 is 3, so A over B here is 2 over 3. This is the second idea. The third idea, that sometimes I give you the ratio of the volumes and you have to find, you have to use the ratio of the volumes to find the unknown surface area. Like there's a relation between these two ones here. A cubic over B cubic and A squared over B squared. Like this example here. Here now, they give me the lateral area of two similar paint cans. They give me the volume of the small can, and they ask me about the volume of the larger can. So here I have two cans. The first one and the second one. The first one here, they told me that the lateral area of it is 1019. And for the smaller one, the lateral area is 425. The volume of the smaller one is 1157. Let's write the volume, or let's find the volume of the second one here. Here now, as I told you, this is the third thing we can do it. The first one, I give you the scale ratio. Yeah, here, okay. I give you the scale ratio. You can find, like, it's make like triangle. You can find the ratio.
Teacher, aren't they asking for the volume of the larger can?
Yes.
But you want the unknown as the smaller can.
Okay, I wrote the name. So now, here, this is the scale ratio. From the scale ratio, I can write the ratio of the surface area and the ratio of the volumes. Sometimes, no, sometimes I give you the ratio of the surface area and I ask you to write the scale ratio. Sometimes I give you the ratio of the volumes. You can write, or I ask you to find the scale ratio. And sometimes you will use the ratio of the volume to find the ratio of the surface area and then find the unknown surface area. Or you can use also the ratio of the surface area to find the unknown volume. In this problem here, as you see, we have two cylinders. We have two cylinders. They give me the lateral area for each one. They give me the volume of the smaller one, and they ask me to find the volume of the larger one. Now, let's start with the lateral area. The lateral area for the first prism over the lateral area of the second prism, it gives me the square of the scale factor. So, 425 over 1019 is A over B squared. But I didn't need A over B. I want A over B only. So as we did before, square root. Why I choose the square root? Because to cancel the square root here. So A over B, it will be the square root of 425 over 1019. Nine plus 1 is 10, plus 1 is 11. It can be divided by 5. It cannot be divided by 3. Let's see here before 125 other 101.
Teacher, I got it as 0.269 because
yes, cannot be
there is no.
Yeah, me too.
I see there. So 0.64. This is now the A or the scale ratio A over B. After I found this one, I need to find the second volume. What does I have to do then? I will say, I say that I need to find the unknown volume or the second volume. So which is, so to compare or to write the ratios of volume, I need to write the cubic of the scale factor, because the cubic of the scale factor is the volume, there's the ratio of volumes. So if you write now the cubic of the scale factor, you can find the unknown volumes, the smaller one over the larger one. 0.64 cubic is 1157 over the volume. So let's divide 1157 over 0.64 cubic. You will find that the volume of the second shape is 4,413 centimeter or cubic centimeters. Here it's like two steps. From the lateral or from the surface area, you will find A over B. The cubic of A over B, you will write the ratios of the volume. From the ratios of the volume, you can find the unknown volume of the solid, shape. Yeah. Is it clear?
Teacher, I got my ratio, I got my volume as 4,301. I don't know why.
1157 over 0.64 cubic. 4413. What did you write it as 0.64? Exactly.
I wrote it as no, I wrote it as 0.646.
Ah, that's right. Your answer is what? 6,000? Sorry, 4,000?
301.
Oh. 0.646.
Teacher,
Yes.
can you repeat the last word?
Yeah, wait. Yeah, because you write it more accurate. There's no problem. Yes, I will not if you write it like this, there's no problem, because I know that you write it, or you choose 0.646, not 0.6.
Oh, okay. Thank you.
You're welcome. Okay, now let's repeat the last part here. Here now, as I told you, you have the lateral area of the two shapes, of the two solids. Sorry. From the lateral area, you can find. From the lateral area, you can find the ratio of the square of the scale factor. So the ratios of the lateral area give me the square of the scale factor. That's mean I have 425 over 1018 is the square of the scale factor. But I didn't need the square of the scale factor. I need the scale factor. Put both of them under square root, you will find A over B. After I find A over B, the question here, find the volume of the smaller can. Like when I told you before, if you have here the scale factor, the triangle that I drew it before, if you have the scale factor, A over B, this scale factor, if you cubic it, you will write the ratio of the volumes. So if you cubic, or if you write the cube of the scale factor, you will find the ratio of the volumes. What does it mean? That means if I take this number, 0.64 cubic, I write the ratio of the volumes. The ratio of volumes, what does it mean? That's mean the first volume over, here, since here I write smaller to larger, so I start with the smaller one to the larger one. Then one variable is unknown, which is the variable of the larger shape or the larger figure. You can do it like this: 0.64 cubic times V over equal 1157 over 0.64 cubic over 0.64 cubic. After that, you will find that the volume here is 1,000, or what was it? It was 3,000, or no, it was 4,413 maybe, and so on. This will be the volume of the second shape. I will do now another example for you. If you didn't understand it, tell me. Okay, who asked me, Maya or Sarah?
Maya,
Okay, Maya.
but it's clear.
Okay, I will solve this problem here now. The volumes of two similar solids are 128 meter cubic and 258 meter cubic. So here they give me, they have two, what are the shape? Two solids, without telling me what are these two shapes. We have two solids here. This is the solid, the first solid as an example, and this is the larger one. Now, the volume of the similar one is 128. And the second one, it was 250. The surface area of the larger one is 250. What will be the surface area of the smaller solid? So here, as we did, I have the ratio, or I can write the ratio of the volumes. So the ratio of the volumes, okay, it gives me the cube of the scale factor. So the ratio of the volumes, it will be 128 over 250. This will be the cube of the scale factor. But I didn't need the cube of the scale factor. I need only the scale factor. What I have to do? Cubic. So under the cubic root, under the cubic root, to cancel the cube. They cancel each other now. Say A over B, it will be. If you simplify it without calculator, you will find 64 over 125. The cubic root of 64 is 4 over 125 is 5. It will be 4 over 5. You can do it also on calculator here, like 128 over 250, which is 4 over 5. So by this step now, I find the scale factor. But that's not what I need. I need to find the surface area. Now, to find the surface area, as I told you before, the ratio of the surface area of the first one over the ratio of the surface area of the second one, it tells me the square of the scale factor. Tell me the square of the scale factor. So this over A over B, let's square it here. I will write the surface area of the first to the surface area of the second. But the surface area of the first is unknown, and the surface area of the second is 250. So let's continue now as 16 over 25 equal the surface area of the first one times 250. So the surface area it will be 16 times 250 over 25. By simplifying, you will find now that the surface area of the second shape is 160 centimeter squared. Is it clear?
Yeah.
Yes.
Yes.
Okay. Let's now do this example here. This is number 18. The volumes of two similar figures are given. The surface area of the smaller figure is given. Find the surface area of the larger figure. So they give me now the surface of the smaller figure is given. Okay, so this is the volume 1. This is volume 2, and this is surface area of 1. As we did before, the ratio of the volumes, it tells me the cube of the scale ratio. So 27 over 125 is A over B cubic. To find A over B, let's put each term by a cubic root.
Teacher, are you writing on the screen?
Yes.
There's nothing because
It is showing for me though.
Yeah, me too.
Me too.
So maybe you have a
but
problem.
teacher,
So here, to cancel the cubic root, or to cancel the cube, write a cubic root. So A over B, it will be the cubic root of 27 is a 3, and the cubic root of 125 is 5. So I find now the scale ratio. Then we say that the square of the scale ratio is the scale is the is the ratio of the surface area. So let's square now the scale ratio, which is 9 over 25. If you square it, you can write the ratio of the surface area. The ratio of the first shape is 63, and the second one, I need to find it by cross product. So 63 times 25 equal 9 times SA. Divide by 9, divide by 9, 7. So the surface area, it will be 25 times 7, which is 175 inch squared.
Teacher,
This will be now the surface area of the second shape. Yes?
teacher, from where you bring the 9 over 25?
If you square these two